things that you think that you know about really well. But before I get started, as anyone who's ever been to one of my talks before knows, that I like to present books at the very beginning, book recommendations. If you have not read this book, you should. It's called Patterns of Enterprise Application Architecture by Martin Fowler. This book informs this presentation. One of the great things about reading this book is you will not discover new tips and techniques for how to write your programs. When you read this book, you will discover things that you're already doing. The great thing about this book is that it will give you a vocabulary for the things that you are already doing. For example, if you have a class in your application whose only job is to go out to the database, specifically one table in the database, get data out of that table, bring it back to PHP, and then take that data and move it back to the database, you could give that long description if you wanted to, or you could say, this class is a table data gateway. That is the power of this book. It gives you a vocabulary so that you can communicate efficiently and effectively with other developers. We already had a very nice introduction. Thank you for that. The important thing, though, is this book, Modernizing Legacy Applications in PHP. I said that the Patterns book earlier informs this talk. This book led directly to this talk. So as an overview, what we're going to be talking about today, first of all, is how we make decisions when we are trying to solve problems, or at least how we think we make decisions versus how we actually make decisions. And after we go through that, and we go through sort of a methodology on decision making, we'll apply that methodology to a problem that we have, legacy code. Specifically, how do we organize our code bases? We're going to come across Model View Controller as one way of solving that problem, but then we're going to decide that maybe it doesn't work out so well in some cases in server-side applications. We're then going to rethink our opinions about Model View Controller and end up hopefully at something called Action Domain Responder. So first of all, how is it that we go about making decisions in the workplace? And I need to point out that none of this narrative is directly from me. All of this narrative is from a guy named Peter Drucker. He wrote about this in 1966. So this is very old advice. It's a very old story about things. But as your grandma will tell you, sometimes the old stories are the best stories. So let's say we've got a problem at work. Doesn't matter what the problem is. We'll just say the server's on fire, right? Now, after we put out the fire, we want to make some decisions about how to make sure that problem never, ever happens again. So we're engineers, right? We're rational, intelligent people. We love science. How do we start making a decision? We start by saying to ourselves, well, we'll just get the facts. And after we get all of the facts, they will lead us naturally to the proper solution for the problem. They will lead us to a good decision by themselves, right? That's what we think about. So let's think about the server getting on fire and start with the facts. Well, wait a minute, here are some facts. It's true that water boils at 212 degrees Fahrenheit if you're in the United States, or 100 degrees if you're anywhere else. If the Sahara Desert is in northern Africa, that's a fact. It's a fact that the Earth orbits the sun at about 93 million miles. All of these things are facts, right? We want to start with the facts. Right now you're thinking, what does that have to do with anything? Why are you bringing this in? Yeah, they're true. But how are they relevant to this current situation? How are they relevant to making sure the server doesn't start on fire again? It turns out that we do not ever start with the facts. There are too many facts in the world to start with. We have no way of figuring out which facts to include in our decision-making process. So as it turns out, nobody starts with the facts. Everybody starts with criteria of relevance. These criteria act as a filter against the infinity of facts in the world so that we can figure out which facts are relevant to the problem at hand. What becomes interesting about this is that this filter that we have is a function of a pre-existing worldview that we already have in our minds. Everyone starts their decision-making process not with the facts, but with this filter that they have gotten from their worldview. This worldview is developed by our observations of the world and our experiences with it, our individual experiences. And those observations and experiences become knowledge for us. And then we have to organize that knowledge according to some sort of theory. And then we develop opinions about how to apply that knowledge to new situations. So this is our pre-existing worldview that we bring to every decision that we want to make. through which we filter all the facts that we're going to use. What becomes difficult then is when we need to make decisions with other people. If person A, with worldview A, comes up with a set of facts that he thinks are relevant to the situation, but then person B, with their worldview, they come up with a completely different set of facts, both of which, by the way, are completely true. They both are just different, even though both sets are true. So then what do? You start arguing about your opinions. Why are you proposing this solution here, and why are you proposing that solution there? They're both set based on true facts, but neither person recognizes the other person's worldview. So now we need to decide which worldview is the right one. Well, first of all, we need to remember that any proposed decisions in this conversation are not based on, again, the facts. They are based on a filtered set of facts. They are based, in fact, on opinions. So each decision that is led to by these facts that you have filtered out, each of those decisions is based on an opinion. So that's the first thing you need to recognize. I want to caution you right now. I am not telling you that just everything is an opinion and everything is equally opinion and nothing is better than anything else. That is not what I am saying. Now, it is true that the proposed decision is based on opinions, but the proposed decision in and of itself is a hypothesis. And different hypotheses can be more valid or less valid than others. So when you're in a conflict in decision-making, the point is not to argue about your different opinions. Don't argue about your worldviews. What you do is you test the hypotheses versus the circumstances of the goal that you're trying to achieve. So if you've got the server was on fire, you test your hypothesis against the circumstances that led to the server getting on fire. And then you observe the results. And whichever result set that comes back appears to work, that's the most valid proposal for the decision to make sure the server doesn't go on fire again. Even better is if multiple people can apply that same hypothesis and in testing it, come up with the same results. So replicability is another indicator that it is a valid hypothesis. So let's say you go through this process. You have an argument, you come up with two different decisions, you test them, you figure out which one is better. A few things can happen as a result of this. It's going to have an effect on your worldview. This is new knowledge. These are new observations of the world. If it turns out that your hypothesis was the one that tested well, obviously it's going to reinforce your pre-existing worldview. You're going to think, yes, my opinions are correct, they are valid, because my decision was valid, and that's perfectly reasonable. But if it turns out that your hypothesis is not the one that tested well, you have to be very careful. First of all, you do have to make sure that the test was a correct one. But if it turns out the test is correct and your hypothesis merely was not the valid one, you have to be careful against rationalizing the disconfirmation of your hypothesis. Now, it's true that we're all smart people here. Smart people are very good at figuring things out, but what smart people are really, really good at is rationalizing why they weren't really wrong in the first place. If only this had been different, then I would have been right. Well, this other thing was wrong, and my hypothesis, my view of the world is still valid. So you have to be careful about this. Richard Feynman tells us that yourself is the easiest person to fool. When your hypothesis turns out to be incorrect, try not to fool yourself about it. And if you can manage to do that, what that means is you may have to accept that your criteria of relevance prior to this point were not appropriate for the situation. You can then begin to revise your worldview so that your ideas are more in line with observable reality. You may revise your worldview. You may completely replace it. So this is the methodology for figuring out how we make decisions and making effective decisions. One more caution. This sounds a lot like a scientific process. I was speaking with a physics major earlier yesterday, and I pointed this out. Ernest Rutherford, the father of nuclear physics, said this. He says, there is only one science. It is called physics, and everything else is stamp collecting. Now, that sounds a little self-serving. Of course, a physicist would say this. What it means, though, is that physics provides a body of knowledge that gives you a predictive capacity. Given certain starting circumstances, we know for a fact that over time, within certain parameters, the end result will always be the same, no matter who it is that's running the experiment. That is not necessarily true for what we're doing today. What we are doing is stamp collecting. We are collecting observations about the world. We are organizing that knowledge that we have collected. We are generating a theory for how to organize it. We're finding patterns in it. And then as we gain new knowledge, we can find new patterns in that knowledge. So all of the information that we have gathered is observably true, even though it may not be predictively true. So the further you get from physics, the further you get from science. And today's subject is very far from physics. So what decision is it then, given that methodology, that we're going to try to make today? What we're going to try to do is organize this code. Who here has seen this code before? Everybody! Some of us are still working with this kind of code. And we laugh, but everyone here has written code like this. 328 lines of spaghetti mudball mess. The decision we're going to try to make then is, how do we organize this? Of course, when we look at this, the first thing we have to do is decide how we feel about this code. And how we feel about this code is we want to get rid of it. Everybody wants to nuke the thing, scrap it, rewrite it, start it from scratch, nuke the thing from orbit. It's the only way to be sure. You do that enough times, you realize it doesn't actually work. Scrapping the code is always a bad plan. So after a while, you learn that what you need to do is reorganize it, refactor it, so that it becomes comprehensible. We want to make sure that we can understand what's going on. We want it to be maintainable, so that if we touch some code over here, nothing over here breaks. And we want to be certain that nothing will break. We want to write tests for it. Chris Hart, just see if he's in here, is smiling his little grumpy heart out right now. So how do we go about doing that? Because we don't generally have apprenticeship programs anymore, we have to go to the next closest thing, Stack Overflow. So we go into Stack Overflow and say, I've got this mess, what do I do? And some really helpful person comes back and says, you need better separation of concerns. Okay, what does that mean? Well, basically it means all the parts of the code that do one thing should be separated from everything else, so you can just address this one concern without messing with any of the others. That sounds nice. Which concerns do I separate, though? This is not really that helpful. We've just rephrased the question. How do I organize my code? You organize it with separation of concerns. All right, which concerns do I separate? So you go back to Stack Overflow. And at some point, someone will tell you, you need to use Model View Controller for your server-side application. What's Model View Controller? Well, we generally hear, either by discussing with other developers or by Googling it, that Model View Controller is a pattern that was designed in 1979 by a guy named Trygve Renskog for Xerox PARC when they came up with this new graphical user interface system for desktop applications. He came up with this because Xerox PARC was having trouble figuring out how to organize their applications. Up until that point, everything had been command line, batches, green screen, maybe punch cards, and they needed a way to organize their applications so that their developers could make sense of them. And what Renskog came up with was a separation of three concerns. The model, which is all the data source and business logic. The view, which is everything that you see presented on the screen. And the controller, which receives input from the keyboard and the mouse, and then translates that through to the model and the view and tells it to draw things on the screen. So that was 1979. In 1999, Sun Microsystems got their hands on this pattern and said, hey, we've been writing spaghetti mudball code. How can we organize it better? We'll use Model View Controller. And with some modifications, this is how it translated through. We've got the controller handling the HTTP request, model still handles the business logic and data source work, and the view generates HTML to send it out to the browser screen. That sounds pretty nice, actually. That's a good separation of concerns. Now we have an organizing principle. Now we have an opinion. Now we have a world view through which we can filter the facts of our code. And in fact, that is what I do in this book on modernizing legacy applications in PHP. At the beginning of the book, we do some setup work, but then we get to the point where we start extracting the data source logic, we start extracting the domain logic, and start extracting the presentation logic. So let's see what that looks like in that code base that we looked at before. So there's the original, 328 lines of mess. First thing we do is extract some data source work. And as you can see, the data source work ends up in these table data gateways. So that if you ever need to add SQL to the code base, it doesn't go into this part of the application script anymore, it goes in a gateway. And in doing so, we have reduced it by some number of lines, 328, 265 lines. And then, with those in mind, there are those, we then extract all the domain logic into a set of transaction scripts. And all of the domain logic is now hidden behind this class. And that gets us down to 98 lines. This is becoming a lot easier to understand. It's more maintainable now. Then, after going through those, we start separating the HTML, and we get all of the HTML generation down at the bottom of the screen, or down at the bottom of the script, so that those things are nicely separated. And then to make sure that we can make this a little more testable, we no longer echo HTML directly from what will become the controller code. Instead, we put it in a template. So we've got a template system now here at the bottom. We give it the variables from the business logic. And now it's easy to see which portions of this are the model and the view and the controller. Here's some setup work that is easy to imagine being in a container in your front controller or in your dependency injection container. The actual business logic here, and then the template that generates the view, which is the part that you see on the screen from HTML in the browser. You do that enough times, you start to feel like you know MVC pretty well. In fact, you stop writing spaghetti code and you start writing code in Model View Controller in the first place. But there ends up being kind of a, I'm not going to call it a problem exactly, just something doesn't quite feel right. Where do those header calls go in Model View Controller? Where's the right place for those? Well, it can't be in the model. It's not business logic. Can't be in the view. You don't see it on the screen. It has to go in the controller. That's really the only place left in our application architecture for that kind of thing to go. But what happens when you call header? Send something to the browser, right? That header, just the same way Echo would send HTML directly to the browser. Sending header sends a browser to the, or sends a header to the browser. And that doesn't, I don't know, there's something about that that doesn't seem right. So this is the point in writing the chapter on presentation in the legacy book, where I started to have a little bit of cognitive dissonance. There's a little bit of friction going on there. Because we've met a lot of our goals. The code is clearly more comprehensible. We can understand what's going on. It's more maintainable. Everything is nicely encapsulated, well separated. It's more testable. Well, it's mostly more testable. I mean, the model is more testable, surely. The view is definitely testable if you wanted to test your HTML and make sure that everything, all the data is getting put through right. But that controller, how are you going to intercept those header calls in a test to make sure the headers are being sent properly? I mean, if you're doing an application level test or an integration level test, sure, that'll work fine. But in a unit test, tough to intercept those header calls. So what do we do here? We go back to Stack Overflow. Stack Overflow says, oh, you need to use a response object then. The same way that you are buffering all your HTML in a template, you need to buffer all your header calls in a response object. And that actually works out pretty well. Here on line 26, you see we create a new response, and then instead of calling header, set status code, we say, hey, response object, when you go out, use this code. Hey, response object, here's the body of the HTML that I want you to use. Just hold on to that for me until I'm ready to actually send the response. And then you can inspect that. So the controller, instead of returning the HTML, it returns this response object, and now your unit test can inspect that response. So all is well, right? I don't know. It still doesn't feel quite right. Why is setting headers and building a response the job of the controller? I didn't think that was what it was really supposed to be doing, was it? So I finished the chapter on presentation, published the book, and then went back and did some research on Model View Controller. And I learned and relearned and was introduced to a number of things that began to change my opinion. First of all, let's think about the origins of Model View Controller. Model View Controller was designed for an in-memory, desktop, client-side, graphical user interface environment. And that seems straightforward enough until you dive into the paper from Reenskog and you realize that Model View Controller in this environment is not a simple thing. There is not a single Model View Controller setup for the application on the client side. Instead, there is a Model View Controller triad for each element on the screen. Every button has a Model View Controller triad attached to it. Every text field, every slider, every window, everything, including the screen itself, has a Model View Controller triad attached to it. So that screen that we saw earlier is not one MVC. It is thousands of little MVC pieces, all connected to each other through a subject observer notifier system, so that anytime any one of them changes, it can notify the rest of the entire system, hey, I have changed, you all should consider changing yourselves too. And so everything is continuously updating itself on the screen through this event loop of invocations. Think about that for a moment. Does that sound anything at all like what we do in server-side applications? In an over-the-network request-response, shared nothing environment, does that sound like the same kind of thing at all? It doesn't to me. But then the real kicker was this: model view controller is not an application architecture. I'm going to say that again. Model view controller is not an application architecture. It is a user interface pattern. Even Fowler in Patterns of Enterprise Application Architecture categorizes this as a web presentation pattern. Right now, heads are exploding. What do you mean it's not an application architecture? The very first thing you did in this talk, Paul, was take our application and split it into model, view, and controller. How could it not be an application architecture? Let's just hold on a second. Remember that our concept of model view controller on the server side is an opinion. It is a worldview. It is a filter through which we are going to pass the facts of our application. And it turns out that the hypothesis that we arrived at, the organization of our code, that hypothesis tests pretty well. But the outcome at the end leaves us with some dissatisfaction. And based on this observation, based on this result from testing our hypothesis, we now have new information. We have a new observation about the world. Perhaps what we need to do is adjust our worldview. So with that in mind, let's rethink our opinions just a little bit about model view controller. Specifically, let's rethink our opinion about what the view is. What is the view supposed to be? Well, again, remember we started out in the graphical user interface world on the client side. The view is what's on the screen. Clearly, it's the word view. It's what you can see. That's our old opinion. What I want to do is present you with a subtly different opinion. The new opinion is this, that the view is not what you see on the screen. The view is what the server outputs back to the client. Again, that is a subtle distinction. But I want you to notice that this opinion actually fits the facts of our previous opinion. The server outputs HTML, so that fits. But it expands our relevance filter just a little bit so that we can include new things in the view. So let's think about the view as being the server output. In doing so, let's think about what the input is to the server. In a client-side system, the input is mouse clicks, keyboard presses, that kind of thing. And its output is something that gets drawn on the screen. In a server-side application, what is the input? The input is an HTTP request. What does the server send back? An HTTP response. It turns out that this is the real interface on a server-side application. Not key presses, not mouse clicks. The input is a request. The output is a response. Now, suddenly, the idea of model view controller being a user interface pattern begins to make sense. And it turns out then that when we think about how to organize this code, that the template system we've been using to build HTML and thinking about that as the view, that is not the view. The view is the entire HTTP response, both the body, where the HTML goes, and the headers. That is the key distinction here. So instead of thinking of the template as the view under the old opinion of the view being what the user sees, we then move on to the idea that the view is the response because that is what the server presents back to the user as its output. What this means is that our presentation layer in our server-side application is not the templating system. The presentation layer ought to be everything that goes into building the response. That is the concern that should be separated. That means that all of these header calls, status calls, anything that sets cookies, that goes in this response building layer. Of course, we need a name for this. The name that I have chosen for this is responder. Makes sense, right? It's the thing that builds response. And so all of the response building work, all of it goes in the responder and nowhere else. As a side note, this actually helps us make sense of things like JSON and XML responses. Yes, they go on the body, but does the user see them on the screen? No. But they are part of the server output. They are part of the presentation. They are part of the view. They are the response. Let's back up for a moment. So what does that look like? Instead of having this template at the bottom, instead, we build this responder object, and we give it the same variables that we gave the template, but then we say, hey, responder, here's the data you need to build a response. Take this data, do it. I don't want to know anything about it. Just give me back the fully formed response. And then I can send that, and I can return that instead of returning HTML. So all that work ends up going into the responder. And now it's very easy to see what the core of our controller logic ought to be. It's all right here. Really all it does is take some input, call the domain, call our model, get back the model result, give it the responder does its work. I don't know about you, but I find that to be a much more satisfactory arrangement of concerns. There's no more question now. Where do headers go? They go in the response. They go in the responder. The responder is well isolated from the model and the controller. You can test it completely independently from anything else. You can give it whatever data you want and get back the right headers in that response. And the responder sets all the headers and uses the template system, etc. And it returns the response object, and you can test that. I find this a much more satisfactory outcome. I think this is a better hypothesis. I think it works out better. And if you need a separate authority to tell you that things actually ought to be this way, I can't believe it took me this long to discover it, but Fowler, again, wrote the book on patterns of enterprise application architecture, but after he wrote that book, he continued cataloging patterns. You will find this one on his website. It's called separated presentation. You already know what separated presentation is. What it means is that presentation logic should not be doing business logic. That's it. But in different user interfaces, that presentation is going to be comprised of different things. In a command line environment, it's printing stuff and taking stuff from the keyboard. In a rich client, it is drawing things on the screen. And in a server-side web application, it is the headers and the HTML. Those things should be separated. Those things are presentation. So we've only modified one bit of our opinion about Model View Controller at this point. All we have said is, instead of saying what's on the view being what's on the screen, the view is the entire response, because that's what's coming out of the server. But what's funny is that it leads you to different consequences thereafter. Like dominoes, as you start applying this, you realize that there are other things that make more sense. The first thing you're going to realize is that responders are just one more thing to inject into your controllers. Let's say you've got a controller, browse, read, edit, add, delete, 5 methods. You're probably going to need a responder for each one of those. So what you're going to end up doing is injecting 5 responders. Well, that kind of sucks. Why should I have to do that? Well, then you're going to realize that, well, maybe what I need is not a controller of 5 methods. What I need are single action controllers. These already exist in the world. Anyone who's using Slim is using single action controllers or an invocable controller. And once you start moving towards that, where each of your actions is a class in and of itself, they each get their own constructor, your constructor signatures are going to become much smaller. You're going to be able to give each action exactly what it needs and avoid, for example, the code smell of action injection. You're going to give each action only what it needs, including its responder. And that, in turn, is going to lead you to better domain logic patterns. Anyone who attended the hexagonal talk yesterday from Nicholas Carlo will recognize this. This is the clean code onion architecture. The idea here is then in your controller, you're going to start moving away from data source patterns like active record, and even away from using repositories in DDD directly towards things like a service layer, as described in patterns of enterprise application architecture. Or in its simplest case, just a transaction script. You're going to be able to extract all that logic, put it over in your domain layer where it ought to be, and then it becomes testable. Or maybe if you like DDD, you'll use an application service. And then you'll be able to test that. Maybe your application service goes so far as to return domain payload objects, which are coarse-grained objects that encapsulate both the data that comes back from the domain and the status of the domain at that point. Again, domain payload's a really nice pattern. Or maybe you're going to use a use case if you're into hexagonal. All of these things end up being variations on the same theme, that theme being that we get all of our domain logic nicely encapsulated away from the user interface. And once you have done that, you will have arrived at a pattern that I now name, or that I've named Action Domain Responder. And I want to be very clear about this. I did not invent this pattern. Every single one of these elements already exists. The action idea exists in terms of SLIMs, single action controllers. Silex did the same kind of thing. The domain is just a replacement of the word model so that we can break with the old terminology. And the responder we've already talked about at great length. So an action domain responder, all the action does is takes input from the request, gives it to the domain and gets back a result, passes that result through the responder, gets back a response. Your actions will end up looking, if you're in a good case, 3 lines. It'll be super simple and super easy to test. The domain then is just the entry point to your domain logic and the responder we've talked about at length. So to sum all this up, at this point, hopefully, we have seen what it is like to make a transition from one worldview to another. First of all, by understanding that nobody starts with the facts. We all start with a worldview through which the facts are filtered. And the only way to make a decision is to test that decision against reality in some fashion and see what the results of that test look like. We went through an exercise of that methodology by applying it to a code organization problem, realizing first that model view controller was the advice, and we tried it out, and it mostly worked. There were a couple little problems. Then we revised our worldview. We tested a couple of different things. Then we applied the hypothesis that led from that opinion against the same code base and came out with what I think is a more satisfactory outcome, transitioning then from model view controller to action domain responder. I hope that's been interesting enough for you today. If you want to learn more about Action Domain Responder, obviously I can talk about it here, or you can go to the paper at my website /ADR. If you want to buy a copy of the Legacy book, Baby Needs a New Pair of Shoes, go to Lean Pub and get it. And please remember to rate this talk at Joined In. I'm happy to take any questions that you've got right now. We've got about 10 minutes left. I'm going to take that as a no for now. Everyone's still waking up. All right, if there's nothing else, thank you very much for your time and enjoy the conference.